the most purpose of coating is for corrosion protection, but some also are used for the some aesthetic, means that for appearance, aesthetic appearance, and some also used for wear resistance. So it depends on the material that you are coated. If let's say the coated for wear resistant, it should have a better properties to adhere the abrasion process. But the common one is for corrosions process for the corrosion resistant. So we have a few coatings techniques that we're going to learn in this lecture. So today's I only will cover on the electroplating, electroforming, and also another one might be electroless. And if let's say I have time, I will actually cover also the hot dipping. Okay. Okay. So this is actually the family of coating. This is actually the related process on the coating. Can you see? Okay, so we will cover on electroplating, electroforming, electroless plating, and hot dipping. I'll try to cover until hot dipping. Okay, if for electroplating, so we are actually moving the ions, then we are going to place the ion by moving of the electron. But same goes to electroforming. So the difference between electroplating and electroless plating, we don't use any current. So it's actually the chemical reactions inside the what we call that one compound. It's actually react to actually reducing the ion to nickel atom, or it depends on what you coat, either nickel, phosphorus. So they will actually reduce to nickel ion, then after that reduce to nickel atom, and this will be the driving force is actually during the process of chemical reaction. All right. So we also have the second coating process, which is conversion coating. So sometimes they are actually mixed two process. So sometimes they combine electroplating and plus the conversion coating to ensure that there are two protecting layers, so that we can actually minimize the corrosion process. So for chemical conversion, we have chromating, we also have phosphating. So anodizing also is actually fall under conversion coating. So the third one is a vapor deposition. So we have physical vapor deposition. We also have chemical vapor deposition. So this process is actually you have study during as semiconductor fabrication. I will not touch much on this process, but I'll just go through very fast on this process. And the last one, we use thermal spraying. So we have high velocity oxygen HVOC. C apa saya lupa? High velocity oxygen super. HVOC. So you also have the common one, the flame spraying, that using the either you use ceramic and actually you are spraying on the surface of your material. So most of this process is actually used for wear resistant. All right, so we will go for electroplating first. Okay, before that, okay, we can see here that you can also see that there are some materials that not require coating. For example, like stainless steel. So stainless steel, you don't have to put the stainless steel part, right? Because it's already have a protection layer, which is chromium oxide. So that's why make the stainless steel become stainless. But you can see also aluminium. So you can see aluminium that use at your house, dekat apa? Frame tingkap, right? So the frame of the window. So if you can see, there is no coating or there is no painting on the aluminium, because aluminium is able to react with oxygen in the air, forming aluminium oxide, which is ceramic, right, on top of layer of aluminium. So this will actually form a very hard protection or very hard surface on the top of aluminium. This actually protect the aluminium from further corrode. So this is the nature of the material. So we also have brass. We don't call as corrode because it actually when the reactions of aluminium with oxygen is actually forming another process. So, but that is actually not deteriorate. So what you mean by corrosion, it will deteriorate your sample, right? For example, like steel. Steel will form Fe3O4. Steel also will form Fe2O3. When steel form these two layers, so it become a protective layer on the steel. But after a longer period, then this oxide will react with oxygen and also water. So they are formed FeOOH. So this actually, when this forming, what happen? Steel will be deteriorate. Maksudnya steel tu akan jadi lebih, tak akan jadi kurang. So maksudnya dia dissolve. Dissolve tu masuk dissolve tu dalam solution. Apa kata yang sesuai? Deteriorate lah. Dia maksudnya dia berkurang. Maksudnya kalau daripada this size, dia dah berkurang. So but aluminium in other way, they also are forming another structure, but the structure of you punya apa frame tadi tak berkurang kan. So dia mengalami proses kita tak panggil dia rust. They are also experience a process of kalau kita lihat daripada equation, they will form another compound, but it will protect the aluminium. Aluminium tu tak akan jadi deteriorate, dia tak akan jadi nipis. Maksudnya dia tak akan jadi dia tak akan jadi berkurang dia punya diameter ataupun dia punya thickness dia. Okay, same goes to brass, bronze and copper. So normally copper, we don't coat copper. Kita tak coat copper. Normally kita insulate because of the copper is actually conduct the electric. So kalau kita pegang, will akan jadi short. That's how we insulate it. But in normal practice, like we use in dalam piping, we don't coat even bronze ataupun brass. Kita tak ada kita tak buat painting, kita tak cat dia. Alright, so so this is actually some of the example of the material that we don't actually paint it. Okay, we start with electroplating. So it's a process of electroplating. So if you can recall back, you have learned in during corrosion process. So it's involved of movement of electron, right? So they will be forming an metal ion. So this metal ion will be deposited on the part that you're going to be coated. So sometimes we call as a electrochemical. So in this process, electrochemical plating. So we have a source. We have a source. So we have a source. So this is the material that you're going to coat. You're going to be coated, right? So this is your part. And this is the material that you're going to coat on this part. So this, the work part is actually the part that your work part. And this is the material that you're going to put on this part. So it become anode. So when you recall back, anode will be will actually reduce the they're actually reducing the electron because sorry, they oxidize and become M plus, right? I have actually drawn here, so tak berapa cantik. So just as such there. Pakcik ni saya di kelas. Saya kau boleh tak? Okay, so boleh nampak tak saya punya drawing yang tak berapa nak cantik ni? So, okay, imagine you punya cincin, ring for your engagement ke whatever. So this is actually a ring that made from copper. Okay, so you want to coat this ring with silver. Okay, so what happened here? So you will be connect the ring to the negative, which is cathode, right? Connect the ring to negative, and the other part that you're going to coat on your ring should be on the anode side. So basically, when you see in this piece of silver, it actually contains all the atom of silver, betul tak? And in this ring will contains all the atom of copper. So when you immerse, this is another solution. So I will talk about solution first. So when you immerse silver in the solution. So this is the behavior of the metal. So when you immerse silver dalam solution, so dia akan jadi Ag+. So dia akan ada, kalau you remember, saya tak sure you belajar tak electrical double layer dalam corrosion. So dia akan jadi, bila di immerse dia akan react, dia akan jadi Ag+. So Ag+ will be sitting this area. So there akan banyak Ag+ here, and electron is also accumulate here. So there is a lot of electron that accumulate in this area. But when we connect it to the battery, so what happened here, the electron can have a path to flow. If let's say no connection, there will be a lot of electron that's sitting at this area. So when you connect it to the battery, so what happened, electron will be moving to the wire. And remember that if you are connecting to the battery, so the current is moving from negative to positive. So current move daripada negative to positive. They also forcing the silver plate to reduce the electron. So electron akan move. So this atom now become Ag+. So atom ni akan jadi Ag+. So atom ni akan jalan-jalan, dia akan pergi bergerak ke dalam solution. So what happened here, electron will be flowing in this path going to copper ring. So this copper will actually receive more electrons. So what happened? So negative dia suka kepada, positive suka kepada negative. So area of copper tadi akan jadi more negative, right? So more negative, so argentum tadi akan gedi dalam sini. So sebab dia suka dekat orang yang berbeza charge, sama macam kita manusia juga. Okay. So and this atom, this ion Ag+ akan receive the electron from here. Electron tadi banyak kumpul kat sini because of this electron are removed from this side and coming to this side. So a lot of electron is here. So argentum will actually combine with electron become Ag. So this Ag, which is a solid, Ag will be deposited on your ring. So the process and we come back to the solution. So solution should have ion that actually we want to play, because when this material was depleted, there will be a less of argentum will be in the solution. So that's why you also must supply enough ion of argentum. So if let's say in this case, we use argentum nitride. So argentum nitride, bila dalam solution, dia akan jadi ion Ag+ and ion NO-3, right? So when this ion is actually inside this material, so they will create a path for the electron to complete the loop. Kalau tidak, electron sampai kat sini, dia tak boleh pergi mana. So they must actually complete the loop. Then only the circuit will be forming. So that's why you need to supply enough argentum so that it can actually plated argentum in here. It's not only come from the this plate. Okay, so in other way, we can say that anode, which is here, is actually experience oxidation, argent Ag, and become Ag+ plus 1 electron. Maksudnya dia buang electron, 1 electron. Electron was giving away. And this electron is moving throughout this wire because they have a path for electron to move. And then at the cathode, you will have another process happen where ion of silver, sorry, I always say argentum, it's supposed to call it silver. Okay, ion silver Ag+ will receive electron from this electron that was supplied from here and forming Ag, forming silver, solid atom. So this we call as reduction. So this is the complete process of reduction and oxidation. So then the ring was plated by Ag, by silver. So you dapatlah one layer of silver that plated on the copper ring. So this process is quite cheap because you just plated a layer of silver. Not total of your ring is actually silver. So that's why they can sell the product very cheap because it has only a very thin layer of silver that coated on the ring. So kalau nak berhati-hati kalau nak terima cincin pertunangan. Nanti kalau coat dengan same goes if you coat with the aurum, with the gold. Sama juga konsep dia. So they have a layer of gold that coated on the either copper or other material. Okay, boleh faham tak proses electroplating? Okay, so theoretically, they are following this law, which is Faraday law. So Faraday law, we can actually calculate how much volume that you're going to plate on the part. So the calculation is actually V equal to C. C is the plating constant, I is the current that we supply, and T is the time. So time for the process to be completed. So this is actually the Faraday law, but in actual, so not all the energies, right? Energy that we supply, remember, same goes to welding. When you give a source of heat to welding, so some of the heat will be dissipated. Same goes to this electrical, right? Not all the energy that from the battery or from other source that used for plating process. Some might be it's actually not actually fully using, right? So what happened here? So we can actually add cathode efficiency. So the amount of metal deposited divided by the theoretical amount. Maksudnya kita kira theoretical dengan amount yang deposit. So we can actually get the cathode efficiency. So we plug in this one in the first equation, equation 1. So the equation 2 become volume of the coating equal to E, the cathode efficiency times C, plating constant time current and time T. So this is the equation that they're going to use to calculate the volume of the plating. So we can also determine the thickness. So if you want to determine the thickness of plating, it's from this formula. So D, the thickness of plating, volume divided by the area of your sample. So you get the thickness of plating. Okay, so this is some of example. For example, that you have plate metal, which is cadmium. So the electrolyte that you use is cyanide. So the cathode efficiency is 90%. So you can have a plating constant in meter cubic per ampere second, which is 6.73 times 10 to negative 2. So it depends on the materials that you use. Okay, I'll give you examples of the calculation. So you can see here. Okay, for example that a steel part. So steel part tadi surface area dia adalah 125. So kita nak plate dia dengan nickel. We want to plate it with the nickel. So what is the thickness, the average thickness of the plating? If you use 12 ampere current and the durations of the plating process is 50 minutes. So kita nak kira thickness of plating. So remember that E equal to V over A. Daripada formula di slide sebelah tadi, coating thickness adalah volume over A. So we know A kita dah tahu. So we have to calculate V. So remember from equation 2, V equal to E CIA, right? So kita ada semua information tadi. So kita ada E, we can get from that table. We also have C, we also have current, we also have time, right? But remember that time should be in the second. All right, so we will get the volume of the deposited, the volume of coating that deposit, then we can calculate the thickness, volume over the area. So we get the thickness of the coating. So this is some of the question that you can actually try. Okay, so this is the methods that they use to apply the coating. So we have barrel. So barrel plating meaning that the component is very small, so they put in the container, right? And we also have another method which is rack plating. So this is on more a big part or more complex part. So they will hang in this rack. They can hang, then only they will be doing the process of electroplating dalam bus. So dia akan deep immerse dalam solution. So it depends on kalau you nak coat dengan nickel ataupun you nak coat dengan zinc, you nak coat dengan apa lagi, zinc, nickel, chromium, but chromium people not use anymore because of the hazardous. So you have this kind of method. So the barrel, you ada rack plating. So nampak dia akan sangkut dekat this punya rack ni, kita panggil rack. So contohnya macam apa, stapler yang kecil-kecil senang masuk dalam, dia akan sangkut dekat ni, hang on this rack. So after that they will be deep in the solutions that contains either nickel, either zinc and so on. So this is another method which is strip plating. So this is purposely for sheet. They will pull this plating through the solution. So they akan, for example, this one they plate aluminium with nickel. So you can see that the shining surface of nickel on the aluminium. Okay, right. So this is the common metal that used for coating, as well as mentioned just now, zinc. So you can actually use either electroplating or galvanizing. For example, like fastener, wire good, electrical switchboard, they can easily plate it because the part is not so big, right? So we can use a plating concept. So why we plate with zinc for steel? Because you remember that from the electrochemical series, zinc is on the bottom, right? And steel is on the top of zinc. So zinc will be sacrificed. Zinc akan corrode because of the more electronegative as compared to steel. So that's why we are using materials that will be sacrificed first. So in this case, we are using a concept of sacrificial anode. So zinc akan makan diri dia dan protect steel. So the other metal which is nickel. So nickel selalunya kita guna untuk corrosion resistant lah, sebab nickel is actually element that actually used for the corrosion resistant. So and you also can use, dia kata kat sini, you can use as a base coat for chrome plating. Means that they will have 2 layers of coating. One they coat with nickel, so after that they will undergo a process of conversion coating. So they coat satu lagi dengan chromating. So there are two process here. So it can also be one process or two process. So this is another material which is tin. So tin is also used to protect. If you can remember that kalau ada tin apa, is coat. So the container is made from steel, right? So they are coated with tin. Dalam dia coat dengan tin for the corrosion protection juga. Okay, if let's say aluminium, it also depends on the materials punya environment. For example, like kalau aluminium, if aluminium in the air, aluminium will not be reactive, right? So that's why reactive is actually depends on the environment. That's for example, aluminium dalam udara dia tak react, dia tak ada reactive, dia tak akan deteriorate. It will be forming another structure, but it's not deteriorate. But when come to acidic environment, so they will be dissolved. When it dissolve, it means that the material will be deteriorate, so dia akan jadi berkurang. So that's why kalau dalam tin can, kita kena coat dia. Kita tak boleh biar aluminium berada dalam, selalunya kan kalau kita minum air yang berkarbonat, yang ada acid, so aluminium tadi akan dissolve. So kita minum, kita akan minum aluminium sekali. So that's why, so normally dia akan coat, but they have to find a coat. Selalu dia pakai polymer. Why they use polymer? Because other than they have to find materials that was resist in the acid. When they are using acid, they will not be deteriorate. So they were using one of the plastic that was not dissolved in the acid. So it will protect the tin can, the aluminium can from dissolve. So aluminium tadi tak dissolve lah dalam you punya air, contohnya Coca-Cola ke Pepsi, because it's acidic. So you remember back, kalau you refer to 4-byte diagram, you can see that where's the aluminium? Aluminium is stable in this area, but it's not stable in acidic area. But kalau still different behavior, so you have to see the material behavior, then you can select the material for coating. Boleh faham ke tak? Boleh faham ke tak? Senyap je, semua dah tak sarapan ke? All? Boleh? Semua dah, mesti orang sarapan sedap-sedap ya, duduk dengan mak. Saya pun rindu masakan mak saya. So all everyday boleh makan mak masak. Okay, then we go to the faham. Okay, so this is others metals that can use for coating copper, chromium. So sekarang chromium kurang digunakan, but still have chromium, but not many people are using chromium because of the hazardous. Okay, so precious metal tadi saya tunjuk example like silver. So normally we can see that on the electronic punya pad, so some of it they are using aurum, or which is gold, to actually to have a better contact. So this is all also they are using plating techniques. Aku tak boleh. Okay, electroforming. Electroforming ni sama dengan electroplating. Konsep ni sama, cuma dia is actually used for the, let's say for example, this is actually the shape of your part, right? So this is actually a plastic, right? So if you want to coat the metal on plastic, definitely you can, right? So what you have to do, you have to spray first this we call as mandrel ataupun macam mold lah. So you want the shape to be like this shape. Tak apa lah, shape ni macam okay lah, boleh lah. Okay, so you want this the shape to be like this. So what you have to do, you spray first. Spray the conductive material on this part, right? So then only you can perform the electroplating. So when you perform the electroplating, so the ion the atom tadi yang you nak coat tadi akan deposit dekat atas this mandrel. Okay, senang sikit, nampak tak sini? So this is actually your mandrel. So you want your part to be like this shape. So what happened here, you have to have metals that you're going to deposit on this. First, we have to spray, sama juga macam electroplating. After spray, then only you conduct a electroforming process, or same as a electroplating. So this will actually oxidize and become, let's say here, if let's say you want to plate this nickel, for example, so become nickel plus, and nickel plus will receive electron from this anode and forming nickel atom. So they will be deposited in this area. But for electroplating, the thickness is very, very minimum, right? But for electroforming, you have to have a certain thickness because you need to remove the part. Faham ke tak macam? Nampak tak contoh ni? So meaning that after it's already formed the structure that you want, then you're going to peel it from the part, from the mandrel. So the part will follow the mandrel punya shape. So that's why you need a certain thickness. If not, it's let's say very thin. So when you remove, it will not forming a structure that you want. So mungkin dia tak sama, dia punya very thin, so it will not forming the structure. It's very difficult for you to remove. So that's why you have to have a certain thickness, then you can only remove from the part of the mandrel. So it will follow the shape of mandrel. So you buat dia macam, kalau you nak buat, tengok ni, contohnya ni muka orang. So you nak buat shape ni daripada plastik, then after that you spray with the conductive, then after that you run the process of electroforming, and they will be deposited of your metal on the mandrel. So after that you separated the coating material from the mandrel. So you get the shape of the mandrel. Boleh faham? So this is some of application. So dia kata fine mold, nak buat untuk lens dye, nak buat untuk embossing, painting. So you can use this type. Dipanggil electroforming. So as application, dia kata mold for CD, DVD and so on. So sama, konsep dia sama. Berapa? Okay, so the third one. So boleh faham tak electroforming? This is not electrophoretic now. Electroforming. Electrophoretic yang tu yang akan belajar dalam, saya rasa dalam semiconductor ke? Ada belajar electrophoretic. So you can differentiate between electroforming and plating. So the third one, electroless plating. So electroless plating, we don't use any current. So all the reactions is by the chemical reaction with the material that you add. So normally they will buy in one compound. So they will add everything, right? So they will add all the chemicals in that compound. We actually doesn't know in details, right? But we as a researcher, we try to formulate our own ingredient or our own composition. So that's how we normally will know what is the item that we're going to play around. But in industry, normally for electroless plating, they will say, okay, I want to plate nickel and phosphorus. So they will tell the supplier they want this and this. So supplier will design everything for them and give them a one solution. So they will use that. But in research, we have to find out because we want to find a novelty. So that's why we actually know each of the compound that they are putting in that solution. Okay, so for example, that we can also plated nickel, copper, gold, sama juga macam electroplating, but they will be more uniform. Electrolysis because they're driven by the chemical reaction, it's not by the electrical energy. Okay, so in this electrobus electroless nickel plating, so they will come with a powder actually. So they will have all these deformation. So the source definitely, if you want to deposit nickel sulfate, nickel. So you must have a source of nickel. So instead the source dia nickel. So they must have reducing agent. So what is actually the reducing agent do? Reducing agent ni akan turunkan, reduce the nickel sulfate, nickel ion tadi to nickel atom. So this is what reducing agent did. So complexing agent, you can use glycine, sodium acetate, sodium nitrate. There are many types of complexing agent. So what did the complexing agent do? They will stabilize the pH. And the stabilizer, we can use copper sulfate, we can use lead nitrate, there are many. So this stabilizer, they will actually try to ensure that there is no decomposition, because when the reduction happen and the movement of the ion towards the metal that we're going to plate, so sometime after a while, when the atom is actually deposited on your surface, what happened? They will be decomposed away. They will be dissolved back in the solution. So that we don't want. So we want the atom that deposit will be stable. So that's why we add stabilizer. And the berapa ni? Number 5. And number 5, surfactant. So we talk about surfactant. So we remember about the surface tension. So definitely we want a lower surface tension. Ataupun kita panggil wetting agent. So kalau kita nak coat, kita mesti make sure that they can actually spread away on your surface. So maksudnya the coating the angles of punya surface tension tu must be less, so that they can separate away nicely on the surface of your part. So there are many surfactant agent that they use, either CTAB, SDS and so on. So but when you buy this in the company, they won't actually tell details what are the materials that they add, what are the composition, because all this will actually form one ingredient. So we just bought this one, and we will actually put in the bath, and then just actually immerse your sample. There is no electrical that actually connect to the component. So you can see here that there will be a reactions of anodic and also cathodic. So because we are using hydrophosphate, so you can also will have a phosphorus depositions on your part. So if let's say you don't want phosphorus, you must control the amount of phosphorus. If you want nickel, electrolysis nickel pure, but sometimes people want nickel NiP, nickel phosphorus. So it depends on what are the composition that you want. So this is also well used in the electronic part for PCB. For the electrolysis coating on the pad of PCB, we can use NiP, we can use nickel electrolysis, we can use aurum, gold electrolysis, gold, unique electrolysis, nickel, gold, combinations of nickel and gold. So there are many. You can actually find later. If let's say you work later in electronics industry, especially those are working on the subcontract manufacturing, which is like Jabil, Celestica, Flaxus, Flax, Samina, and so on. So sometimes you have problems on the wettability. So it might be caused because of the surface area, surface coating, surface coating. So because of additions or because of the roughness, is a lot of problems. So it's not a main problem, but it might be caused because of the coating problem. So you might see different type of coating that was used on the PCB. They also can use electrolysis plating for cutting tools, but it have to have embedded with other material that can give you strength. For example, people are using composite, so they embedded the ceramic particle, then turn the electrolysis become composite electrolysis coating. So they are embedded others particle to add it for the hardness, for the wear resistant. So you can add ceramic particle as well during the process of electrolysis plating. So as I mentioned before, definitely all the process same goes to electroplating. So the process before electroplating must undergo a process of cleaning. So there will be a thorough cleaning for electroplating, even though I didn't mention before on the electroplating. So definitely before electroplating, there will be alkaline solutions, rinsing with water, alkaline again, rinsing with water until a few steps. Then only they do the electroplating. Same goes to the electrolysis plating. So in this example, okay, they will actually ultrasonic first the part and then decreasing the part and then use the acid to clean and activation. So they sometimes need to activate the surface so that it can actually attract the atom to be deposited on the part, because it is used a chemical reaction. There is no force that forcing the atom towards the part. So that's why you need to have to activate the surface of the part to ensure that the material is actually adhere nicely on the part. This is advantages. You can form a uniform coating thickness even though on the complex part. We can use for also for both metallic and non-metallic. So definitely for non-metallic, you have to spray with the conductive. If not, you cannot plate the part on. You cannot plate the coating on the part. So it doesn't use any power so to drive the process. So it's just only chemical reaction. Okey tak? Boleh faham tak? Boleh beza antara electroplating dan electrolysis plating? Kita tak nampak lagi. Nampak ke tak? Tak nampak? Okay. We go to the last part for today, which is hot dipping. So hot dipping is actually we are using a high temperature molten. So either we use zinc or we use aluminium ataupun we use tin ataupun we use lead dengan tin. So semua ni adalah family dia adalah hot dipping. But for zinc, so normally kita kata galvanized steel. So what we mean by galvanized steel means that the steel was dipped by zinc. So we can also call this process as aluminizing. We are dipping the substrate in the aluminium. So we call as aluminizing. We can also call as tinning. Sebab kita dip dia dalam tin. And for lead and tin, we call this as plate. So ini adalah proses dipping in a molten metal, which is at high temperature. So normally dia for corrosion protection. So we have two mechanisms. Either we use barrier protections or before the sacrificial protection. As mentioned before, we have to coat with the materials below our part. So still normally we can use zinc, because zinc is actually less it's actually more electronegative than steel. So this will be corrode first as compared to steel. Barrier protection means that it will allow the solutions or the water to be go inside the steel. So means that if you have some painting, it's also for barrier. You paint your pipe. So when the contact with the environment, even though you cannot see the water in environment, but it has contained some moisture. So this moisture also can react with your pipe. So what happened here, we coat it with the kita guna cat. So maksudnya cat tadi merupakan barrier. Same goes here. If you coat it with zinc, first zinc become a barrier for the moisture or the water or the solutions, any solutions that can be go through the pipe. And the second one for the protection. If let's say corrosion happen, if let's say we cannot avoid the water or the moisture to go in, at least the zinc will be corrode first and leaving the steel behind. Boleh faham? Okay, so I'll take example. So this is the galvanization process. This is galvanizing. So we use to protect the steel with zinc. So we are dipping in the molten zinc. So this is actually some corrosion protection that actually will be forming. So first, when you dip in the molten that contains zinc, so after the process of coating, so you will have a pure zinc, right? That was actually adhered or put on the steel. But after a long period of time, so zinc will react with oxygen in the environment, so forming zinc oxide. And after a few years, a few days, a few months, so this will convert this one to zinc hydroxide because of the reaction with other water or moisture in the environment. So both zinc oxide dengan zinc hydroxide tadi, even though they form a product same like aluminium oxide, tapi ini dia form zinc oxide. But these two product is not actually dia adalah soluble, dia bukan insoluble. If insoluble, they cannot wash away. Kalau soluble, they can wash away through kalau masa hujan dia senang di dissolve. Dia soluble terus. So dia tak protect lah, dia tinggal lah zinc tadi yang dalam keadaan certain part dah kena remove. Maksudnya dah kena react. So and then in order to have a better protection, so sometimes all this zinc oxide juga akan jadi bentuk satu lagi, dia nama dia zinc carbonate. So zinc carbonate ni akan selalunya dia lebih dia akan soluble tapi ambil masa yang lama. So dia akan protect. Saya lupa nak lukis. Maksudnya dia akan ada, dia tak expose the steel. You still have the corrosion products on the top of the steel. Even though zinc is already no more zinc pure, it become another product. So at least they can protect it from exposing the steel. So same goes to electroplating and also electrolysis. So hot dipping also will have a cleaning process. So we decrease it, dip in hot alkaline to remove some of the dirt, grease, and all so on. So after that, we have to rinse again the water to remove all the alkali, and then again we pickling it in the acid chloric to remove or rust or scale, and then after that we rinse again to ensure that all the hydrochloric acid was removed, and then we fluxing with zinc ammonium chloride. So when doing the fluxings, we actually to remove the oxide and also promote the bonding. So we are some sort like activation. We are try to promote the bonding between zinc to steel. Then after that, the last part is dipping in the molten of zinc. Then after the process of finish, then we rinse again. So this is a general step for hot dip galvanizing. So this is for example of galvanizing. It's the same goes to aluminiums, and also maybe there is some step that was not actually used, maybe for aluminium, maybe pickling. I'm not sure, maybe pickling is not actually involved. But if let's say you use steel, definitely you must carry on with the pickling. All right. So I'll stop here. So any question, ada soalan tak? Ke masih ada yang kurang jelas? Okay. Soalan tak apalah, ya tak semester ni saya tak keluar soalan. It's very hard for me to give example of question like calculations, because I think saya tak boleh nak bagi dengan sepenuhnya untuk question like calculation. It's very hard for me to explain without you tengok tak nampak muka you all, dan susah saya nak explain, make sure you all faham untuk because question for calculation, some of it a little bit tricky. Okay, ada soalan lagi tak? Tak ada soalan, kita boleh awal sampai 5 minit lagi. So semua dah balik ke sini? Semua dah masuk dalam school? Dah masuk dalam school, dah masuk dalam USM?
Kat Induk, Doktor.
Kat Induk? Siapa ni? Burhan? You dah